So next, we will have Internet of Things, IoT and Society, where we are, title talk by Sylvain Denoncourt. I hope I pronounced your name correctly. Sylvain is currently responsible for IoT, enterprise network design and architecture with Cisco Systems Canada, specifically focused in solutions for utilities, smart grid, mass transit connected fleet, and intelligent cities. Sylvia is gracious to come here all the way from Montreal to present us.
Thank you. So I just hit the space bar. Okay. Good morning, everyone. Oh, okay. I have to stay here. Sorry. Sorry for the people on the web broadcast. Okay. So good morning, everyone. My name is Sylvain Denoncourt, as stated previously. I'm with Cisco. I'm an IoT architect, and I'm actually based in Montreal, but I gladly accepted the invitation to come all the way here to your lovely city in Victoria. My first time here. Very nice, very nice. Today I will be presenting IoT and IoT and Society, actually. This afternoon we have a second presentation which is more geared towards security, but this morning is more of an introduction of what IoT here, what difference does it make in our life? Is it a breakthrough or a break-off point like Mr. Perkin was mentioning? I will try to convince you that there's good things about IoT for sure. It's a big wave that's coming. It's already here in some cases, but there's a lot more to come. And this presentation this morning will put that into light and give you more of an insight of what and how IoT can change our life, not just for private people, but for organizations. And there will be, in the future time, a strong impact on how we do things and how it can modify the various things in life that we do in our everyday at work. So Internet of Things, where are we? Well, first of all, when we enable things, we've been connecting people for 2 decades. We've been connecting people to servers and services. Now we're in an era where we're actually connecting things. We're connecting objects. There was only maybe 5% of what could be connected to the internet that was connected maybe 10 or 15 years ago. And that 5% was actually the people. What is that 95% left that we need to connect? These are the objects. And there's a lot more objects on the surface of the planet than there are people. So in the end, why do we want to connect objects? The reason is we want to collect information. We want to collect data in order to produce eventually useful information in order to produce outcomes. It all comes down to create efficiency and to make better decisions. So at the end of the day, if we have exposure, if we have visibility on different things that may include process in a manufacturing environment, it could be data for utilities who's trying to see how the power grid is behaving. We can make better decisions at the end of the day and produce intelligent outcomes. So that's what IoT is all about. It's not about just simply connecting a sensor or catching information at a very specific point. It is about what you do with that data that you're collecting. And if at the end of the day you can collect data from so many points, so many sensors in your environment, then you can grab all that data, analyze it, and then produce consistent, relevant, intelligent information. That will help you make a better decision. So in a nutshell, that's what IoT is all about. So what is it we want to connect and why? Different things. Victoria, well, that's the Victoria Line bus in London, but I thought it was cool to have it here. Nice fit for this presentation happening in Victoria. But we could connect bus, make a smart fleet. I'll go into examples of how this can make things interesting for transit authority within cities. Police cars, loaders, fixtures, lampposts, thermostat, transformers. So many things you can think of. The doorknob. I'll even show you something as peculiar as a mousetrap that's IoT enabled. Don't laugh. We actually have devices like that. So it's very easy to realize that in a very near future, there will be a lot of these devices. As people are imagining and thinking of various things that they want to measure or grab data from, it's very easy to think that in a couple of years, this multiplication of different sensors and devices will make it for a huge amount of device out there that will be connected. And so many connected devices need to be managed. Managed in a proper way, managed with an architecture, and managed in a secure way. So 50 billion devices by 2020. I'll let you imagine how it's going to be in 2100 or in 200 years from now. Rest for sure, we can imagine quite a bit from where we can actually grab data. So that means for those of you who are actually involved with IT operations within organizations, IT and OT operations, should I say, is it clear for everybody what is IT? I think is pretty clear. Most of you have seen or heard about the terms IT, information technology. Those are the guys running the data centers and the network, and they're mostly connecting people and servers and services, web services. The OT people are actually the one more concerned about connecting objects. So operation technology, that's what it stands for. And if we talk about a manufacturing plant or a utilities or an environment where you're producing goods, those are more OT people we're talking about. Operation technology, very intimately linked to industrial devices, which encompass lots of IoT. But anyway, right now, whether it's IT or OT, we have nowadays roughly, maybe on average, 200 devices that a potential network administrator, an individual, might be running, managing, and monitoring. Very soon, it's going to be very likely that it could be 100,000 or even 1 million devices. How do you manage 1 million devices? If I was to tell you tomorrow that you need to manage 1 million people on your network, that's a lot of people. 1 million IP phones, for instance, that's a lot of people. How do you manage, how do you get visibility on that and consistent, reaction and consistent monitoring and security on top of that? So these are all questions we need to address as we are propagating these sensors and IoT devices. And since the propagation of these devices are a lot faster than we've been connecting people in the past, then we need to think about this very soon, very early in the process. So how do you address that? The answer, first and foremost, the easy answer to this is by actually considering a structured architecture. You cannot think of adding IoT devices or sensors solely based on the fact that you are talking maybe to different individuals dealing, let's say, with ventilations, or individual dealing with heating systems, or with electric devices or sensors in a car. These are all companies and organizations making devices, smart devices, and they're very good at it in order to collect data. In the back end, though, there's got to be a network. There is an environment, just like we did for IT, that needs to be put together in order to produce a consistent, logical architecture that is secure, and that could be managed. Remember those million devices I was showing you the previous slides? Well, how can you manage that if you don't have a structured network? So that's the whole idea behind a good plan in order to deploy IoT for the future and be prepared for that huge wave that's coming, whereby organizations, cities, utilities, manufacturing plant, oil and gas company will need to deal with. The number of devices is not to be taken lightly. So a couple of use cases here. As I said, this afternoon I'll be more focused on the security aspect and how it can impact a network and what you should be concerned. Here I'm going to be concentrating maybe on the plus, on the positive aspect of what IoT can bring into organization and even in your private life. So here's a typical showcase. I deal quite a bit with cities and smart fleet transportation authorities. Lots of cities right now are actually showing lots of interest in connecting their buses or metros and transportation authority organizations. Why is that? Because there's a lot to be collected from a bus or a fleet of buses, because these are carrying people, lots of people every day. It's a public environment. It's concentrated. Lots of people in the same device traveling every day. So more and more for maintenance purposes, security purposes, to collect data in order to repair these buses and these fleet, maintain their conditions. Also collecting statistics on the fares, tickets being sold, where are those buses going, territories that the buses are covered, in order to produce logical and useful information for the passenger to know when exactly the next bus is going to show up at the bus stop. So all things that you can see on the slide here, a few examples of what are of interest in a connected fleet. And this is all IoT stuff. These are all data that we can collect from a transportation, a truck or a bus or any rolling devices like that you might have in a fleet. So typically how we would look like, this doesn't mean, this is not meant to be a technical and engineering presentation, but just to show you a little bit how we do things. Typically we would put in a bus like that a small router that has capability to connect over different medias. Typically we would see an LTE connection, or at times it could be a Wi-Fi connections. More and more cities are deploying mesh Wi-Fi environment whereby information from a bus could be sent to those antennas. And if you are in a very wide area, then LTE connection via cellular company could be used. In either cases, any information you have in a bus could be relayed through such a device and then connected via the cloud of a service provider and then sent back to the back-end center where you have your data center, where you have servers that can collect that information and make some sense out of it, like send an alarm, something happened in the bus. I'll give you some example here. You see the little motor on the lower left corner, OBD2. OBD2 to serial USB. This is just a converter. There's a lot of conversions happening with IoT. Imagine we connect a thermostat, a motor, a PLC in a manufacturing plant. These are all devices that are all different to one another. So you need some connections that can actually interpret these different data, these different formats, convert them, and then produce useful information. So right now, in all your cars right now, there is a LAN, there is a local area network called a CAN bus, which could be monitored by an OBD connector. These will provide useful information on oil pressure, temperatures of the motors. It could provide information on brakes, pressure, and the mix of air and gas within the motor. So all these information plus cameras that typically you would put in a bus for security purposes. Typically you'd put 8 cameras in a conventional typical bus, 8 cameras for security purposes that can send information only and only then when there is a specific incident or specific event happening, like noise or a gunshot, or if the cameras were to see people moving in an erratic way, then the actual transmission in high definition, could actually be sent at that moment. So there's a lot of that intelligence whereby the transport of data will take place only at the moment where it's needed. So you don't need to actually transport that data all the time and saturate your WAN link, especially if it's a Wi-Fi or an LTE link. You could have valuable information and offer services to your passenger via Wi-Fi. All these things, all these pieces of information could be sent to a routing intelligent devices, especially engineered for transportation and have the robust aspect that you require in vehicle like that. So what can gives you from an endpoint? You could very well have your operations center using an application such as our friend at Davra. Davra is not a Cisco application. It's a partner that's producing this, but we're good at doing network environment, and there's other people good at doing sensors and application in the back end in order to interpret and provide useful, intelligent information. Davra is one of them, but they basically can produce a map of all your buses and all your transit vehicles on a map, show you where they are in real time. If you were to click on any of these icons, you would at that point be brought in with a video of the interior of the bus, of what's happening, telemetry information on the motors, which could be transferred to the garage when the bus head back to the garage in order to produce a report to the mechanic so that that person knows in advance what's going on and then make an intervention faster on the bus and keep the maintenance efficient and fast. And also all kinds of information about the engine or the mechanic aspect of our fleet here. Another interesting things that IoT can bring in, by knowing all the time via a GPS signal and accelerometer, which are usually part of devices like that, driving IoT devices, you can actually do what we call geofencing. Well, create an area into which those buses should operate. Should they come outside of that area, it would trigger an alarm and send information to the control center saying that, well, there's 2 buses that are actually way out of the operation environment, outside of the fences. Therefore, there's something going on. Maybe the bus got hijacked. Maybe there was a construction issue and the bus is all of a sudden, because of an accident, had to go outside of its range. So things like that becomes possible with IoT. There's been projects with school boards as well. That's another example where parents want to make sure their kids got on board the bus. So once again, just via small tags, we can check in or check out the children coming into the bus and know that they are safe and they actually got onto the bus, while at the same time collecting data on the performance and the actual location of the bus itself. So it makes for a safer, a more resilient environment, and it makes for parents and school boards more at ease and also predict also the specifics of the buses and where it's going and what's happening. So everybody is safe, everybody is keen. And so smart cities now, what do we got here? In a city, typically, well, the actual transit operation is one thing, but also within the cities, especially large cities, we have parking challenges. So once again, IoT can help out here. We have issues with lighting. We can be a lot more efficient with our lighting within the city, whereby should we need to have those lamp fixtures turned on at full power every time, sometimes the light may be different, or there could be different requirement based on whether you hit a cloudy day, or based on the time of the year, or based on various environmental conditions that can happen. You have traffic challenges. Why would you be stopped on a red light when there's actually absolutely no cars crossing in front of you in the other directions? Maybe those lights could be a lot more intelligent and counting and monitoring the actual traffic, and then try to turn on and turn off and those lights in a more intelligent fashion. Safety as well. Why can't you use maybe cameras and analytics in order to do license plate recognition and see what's going on? All these things are different areas you can address with a smart city design, whereby at the very bottom you've got your sensors, cameras, you have LoRa sensors, you have device that can even monitor the content of garbage bins or recycle bins, lights, city lights and whatnot. And all these sensors will carry on their information, sometime in different format, but it doesn't matter because we can grab all these different format and these different transport and adapt those different formats in a more common language that could be understood by the various applications that are sitting at the network layer through APIs, and then eventually at intelligent applications at the very top. So the center portion is the actual structured network I was referring to. So you deploy sensors and IoT devices, but in the center, here's your structured network, secured network that need to be architected. Typically, cities have been doing things sometime in an erratic way, whereby they would deploy various sensors or cameras or sensors to collect temperatures or the amount of lights actually in order to control. But these were siloed and different networks. At the end of the day, it makes it for a very complicated network that is very expensive to maintain. So that's why a structured network is truly important when you start to deploy zillions of sensors like that. So that's what I was explaining. Otherwise, you end up with a siloed approach. Siloed approach are very hard to protect. Siloed approach gives you broken down visibility, not global visibility. And if we come back to that slide where I was showing you 1 million devices that could be managed by one individual, can you imagine if these devices were spread out over 5 or 6 or 10 different networks? How do you manage so many devices spread out over so many different networks? And by the way, those networks are all different, and they all produce information in a different way, and they all need their specific secured way in order to protect them. It won't work. Over time, this is going to be a killer. It's going to be impossible to have a logical structure that you can actually grow out of and make sense out of this. So here's another example with city lights. City lights, there's a big push right now of converting, sodium lamps to LED lamps, LED fixtures. The actual move of going to LED is quite obvious in terms of the electricity saving that's behind all of that. Over time, though, while you're doing that move, why not maybe take the opportunity that you're actually putting in new fixtures with LED to maybe potentially put some extra sensors that will help you out do a lot more than just saving electricity by the fact that you're putting LED. Those fixtures now can embed, some of them can actually embed cameras to eventually do smart parking operations. By looking down at the street, you can actually see who's parked and who's not, and what are the spots available within the city. It could be used eventually for security purposes. It could be used for license plate recognition. Why not also put, it's not that much expensive to put a temperature sensors so that maybe you can potentially evaluate if there's a risk on one particular street that there's going to be an icy road, and therefore send an alarm and information to the users of that particular boulevard or street. You could also sense temperature. You can sense certainly the light that's happening. All of this could be used on one single network, as opposed to, in my top example, having different devices doing this via 3 or 4 different networks. It could all be done through an IoT-enabled IP networks that can actually provide all of that on one single infrastructure. So at the end of the day, what can you get out of smart fixtures like that is different things like you can see here. Daylight harvesting is a good one because it is based on the level of light. It will actually adjust the level and the intensity of that street lighting operations, and therefore bring in an even more interesting economy of scales in terms of electricity consumption. So what would it look like if it was to be assembled or set up in a structured network? It would look like this. I'm not going to bore you with too many technical examples, but this is something that can be think of. Mesh networking could be Wi-Fi, it could be LoRa-based networks. I'll show you different types of example, but it could be LTE as well. There's different ways of connecting, but that's not what's the most important. What's the most important is that all of these things, whether you have 3, 4, or 5 different sensors on a street light, is that you actually run that through a one single architect network that's cyber secured. And typically in cities, we would do mesh networking. So we would have devices that will link up to one another and repeaters and create a cell into which lamp fixtures can talk to one another and re-amplify signals and bring that over to the operation center. So at the from an operational perspective, people from the city would actually see their streetlights on an application that could be even on an iPhone for that matter, and see in real time the conditions and the information that is coming, the data that's coming from these streetlights. Smart parking. I was telling you about why not putting a camera. While you're at it, a camera can easily, using analytics, find information as to what spots are available or not. And as you enter a city, you can actually, through an application, get all the spots that are available, and from that even potentially reserve a spot, which would turn on a specific light at one specific location in order to warn people that somebody's coming to take that spot. But at least of wandering around and trying to find a spot, you can actually use your application based on information that is captured by those cameras. So I'll show you an example of how it would work. So in this case, you see the kind of visual that those cameras would see. I've got a little bit of an animation, but I guess over the webcast that's a little bit of a problem. But essentially those green square that you see there are spots that are available, and this is basically the camera that's simply taking a picture of the street, and by doing analytics would just give you would give information to the camera and provide information to the application saying that these parking spots are actually available. If they're taken, then the camera would see that as well, and the analytics software would then claim that spot as being taken, and therefore it would show on the application. Advanced video analytics for maybe security purposes. In this case, why not having a situation whereby if there's suspected individuals that are being looked at by the authorities and the police, you could actually do license plate recognition. Straight from the lamppost, once again, it's no harder for a camera to analyze the license plate. They're already doing it on bridges where or highways when you need to be charged. They actually take a picture, or for these radars on the highways, checking for speeding situations. So you could do that easily while having these cameras on different streetlights and then capture license plate and then focalize and provide information of if different individuals that are actually researched and look for within a city. So different project that's been done. Chicago, Illinois, that was actually with the Transit Authority project that's been done over there. Barcelona in Europe is a great example of IoT. They've implemented a lot of that stuff that I just talked about in order to make life easier and make more the city connected and provide that information in a friendly way to not only the citizen but also the visitors in the city. So at the end of the day, it creates for happier citizens. City agencies get, view and statistics on how their city is being used. It can help out in the planning of urbanism. It can help out in also how to build a more secure area and deal with, traffic optimization within the city. So having the data is what's important here. As long as you have the data, regardless of what kind of sensors it's coming from, you'll be able to make a difference and create outcomes and make an intelligent decision at the end of the day. That's what IoT is all about for many of these organizations. Now I must talk to you. I'm going to get a little bit technical. I told you this is not an engineering presentation, but I need absolutely to talk about LoRa. Who knows in the room what LoRa is? Just a show of hand, a couple of people. Okay, LoRa is quite a new technology. Everybody know about cellular technology, about Wi-Fi. You've all heard about Wi-Fi because you probably all use it everywhere in your life. LoRa is a newer technology because what is it? We don't need necessarily to have huge, sophisticated type of transport to collect data from sensors. The values you actually get from a sensors, those are just numbers and letters. It's very low throughput, low duty cycle. So why attaching or providing to that sensors an LTE or cellular connections? It's expensive for nothing. Why providing a Wi-Fi connection to that sensor? Expensive for nothing, though. Those Wi-Fi technology nowadays are transmitting at 100 megabits or in sometimes gigabits per second of data. You don't need that. A sensor pulling, temperature information or putting oil pressure from a bus or that is just collecting GPS information from a piece of good that you want to track, then you just need a simple technology that can transmit over very long distances, that's low power, and that's low throughput. So there are sensors like that. We call them LoRa, low power, long range. That's what LoRa is all about. It's a new technology that's been put together in the past couple of years. It's mostly been developed in Europe, but it's coming now in North America, whereby by the perspective of seeing those billions of sensors that will need to be deployed eventually, we needed something that could scale and that could be less expensive and that would take less bandwidth than the typical Wi-Fi or LTE. So LoRa suits the bill for that. These are little sensors, cheap, that can last for years. I'm talking 5, 10 years, actually, without changing the batteries. And these sensors are like cats. They're sleeping like cats. They're transmitting at 150 kilobits per second, not megabits, kilobits. That's very low throughput, low duty cycle. And they will send, and there could be thousands of them sending that information to a gateway, which in turn can gather all that information and send that over via an LTE or a Wi-Fi or even a directly connected Ethernet connections. So you see what I'm saying here? We needed a technology that actually was more appropriate for that deduplications of all these sensors that we're going to see appearing left and right in the near futures. And LoRa suits the bill for that. There is another technology that you might have heard, which is called NB-IoT, narrowband IoT, which could also be used for that. So those are sort of competing or complementing technology to one another, but it's the same idea. It's for low duty cycle, low throughput, for thousands and thousands of sensors for which you need to collect data like that, which afterwards could be concentrated onto a gateway, which then eventually connect via the internet, via a secure link, via LTE, via fiber, via whatever. So this is another example of a structured architecture that can deal with multiple and huge amount of data point collection. And this is what you're going to be facing. That's what organizations are going to be facing in the near future. 50 billion IoT sensors by the year 2020. So imagine how you're going to structure that. How you're going to make it. How you're going to build it within a secure environment. So architectures like that need to be taught in advance, and you need to be planned for. So here's an example, actually, of a LoRa sensors that's actually embedded within the street. This is a sensor that I showed you the camera that was actually filming the free spot location for smart parking operation. This is another way of doing it. In Europe, actually in Holland, they've been using sensors like that embedded in the street. So the sensor via ultrasound will actually know whether or not there's a car on top of it and therefore make the spot available or not through an application. You could think of plenty of ideas how you could use these low-cost, cheap, low-duty cycle sensors. It could be used to, in some cases, to track copper reels for utilities. Utilities tend to get their copper reels stolen because it has a significant dollar value, and very often they're being left in a substation, which is not all that guarded, so it's easy to get those things stolen. So by putting LoRa sensors on these copper reels, they can actually track, and using geofencing, know that these copper reels are being taken out of a specific area, and they are actually being stolen. So millions of examples like that you could use. So this is a typical architecture from a technical standpoint. You'd get an IXM gateway like you see in the pose, and then you see those on the top left corner, the LoRa sensors that are actually transmitting. Those sensors are very small. I'll show you after the presentation, but at the break time, come see me and the other Cisco people here. We'll show you examples of LoRa sensors that are actually being deployed. We even have mouse traps that are LoRa sensor enabled. So you know that when you have pest control in a typical building, you know exactly where to go, where these mouses. Otherwise, it's just a manual strolling around that you need to go check all the mouse traps. It could be just as simple as that, but you can see that imagination is going to be driving a lot of those needs in the near future. So if one can think of a mousetrap LoRa enabled, then you can think of many other things that could be LoRa enabled in the near future. LoRa could be used also for geolocation, so you know where exactly that sensor is and where to find it. My copper reel I was referring to with GPS enabled. Mind you, if it's GPS enabled, the battery is not going to last as long. It won't last 10 or 15 years because at that point the GPS is driving more energy. But still, it's going to be years of operations. Traffic management, here's a good example. It started in Europe. Now the intelligent traffic system plan in the US as well. But basically what we want to do, and these are the states that are participating into this, is to make highways intelligent by using a technology called DSRC, dedicated short-range communication, whereby cars in the near future will be able to have a receiver transmitters, a short-range receiver and transmitters that will talk to various antennas along the highway. So as you're passing on a specific highway, your car is going to provide information to the intelligent highway in terms of temperature of the road, for instance, whether there's icy conditions, whether cars are all of a sudden all slowing down altogether. So if you have 1,000 cars providing information like that, it gives a very high resolution information at the end of the day to those intelligent highways that are taking all that data and process that into an analytic software. So at the end of the day, those highways become turned on and intelligent because as a result of the multiplicity of all these cars passing by and providing all their piece of data one by one. The collective information makes it for an intelligent highway in order to reroute the traffic, in order to send information that, oh, there's icy conditions, slow down because in 5 kilometers it's going to be real bad, windy conditions, any of that you can think of. So these are projects that are on the go and are typical IoT type of projects. So connected roadways, greater visibility, improve operational efficiency, better communications for snowstorm, which I don't believe you don't get as much as we do in the east. But these are all things that can make things a lot better for safety, for operation, and make the traffic more fluent at the end of the day. Probably prevent also accident because people and the highway as becoming intelligent will be able to warn people a lot more in advance of what to expect in the later during their driving on the road. I'm getting towards the end. Don't know if we have a time check here, but basically I need to talk about a project, Field Area Network. This is something that actually that's quite interesting because you have a company here, BC Hydro, for which Cisco has done quite a bit of work in terms of distribution automation and smart meters. Utilities are very interested in IoTs as well because, as you know, collecting, power consumption of each and every house and businesses is of interest. Utilities company need to do that in order to charge back, but it goes way beyond that. As you're building a network like that of smart meters, like it's the case here, these smart meters talk to one another. They create their own wireless mesh network. And they eventually take all that information up to a device, which we see here, the router. I'm just circling it here. And this is the concentration router, which actually collects all that information and then sends it back to the data center. You can imagine that beside just collecting, power consumption, we can collect all kinds of information, the habit of consumption of people, and propose ideas how to save electricity to the consumers. Not only that, but we could also use that to do demand response. What is the demand response? It's a way of actually maybe controlling your water heater or some heating units within your house in order to reduce power consumption at specific times of the day. It saves you money, and it send back and keep back electricity in the power grid that could be used for other things, or maybe electricity surplus that could be sold to the US, for instance. I believe BC Hydro is selling to the US, just like many utilities in the East. So, and increase better operation and profits for the organizations. At the end of the day, it also provides for a more and better, more intelligent electricity consumption. So this is a typical picture of actually of a BC neighborhood in Vancouver, actually, whereby you see one of these antennas. If you ever see these boxes, white boxes, those are actually the routers that are grabbing all the information from these meters. These meters, as they're building a network, they could be used with street lights in order to provide information and a network infrastructure in order to give information about transformers and the condition of a transformer. At the end of the day, what can it provide also to utilities gives preventive information about the condition of a transformer. So by collecting data from that transformer that is actually using the same network as the smart meters, we can actually know in advance when that transformer is going to fail and actually operate on it and do an intervention on it before it actually fails, hence improving, you know, the outages and the time those outages could last every year, and preventing, providing at the end of the day a better service for all citizens. So these are examples that could be used with a mesh network on the connected grid. So big things for utilities. You have here typical transmitters that on top of a lamppost fixtures, which is actually connecting on smart meters. So street lights are actually talking to smart meters and providing information. It could be lighting, harvesting also that could be passed through that network as well. So once again, building a structured network, safe, secure structured network, triggers for all kinds of other possibilities, and not maybe solely the main objective that you've been looking for at the very beginning. BC Hydro was looking to collect power consumptions, but once that network is in place, why not collecting transformer information and lighting information as well based on the same network? So here's a typical case of a demand response, whereby you can actually let the utility control your water heater, reduce your electricity cost, and by the same time restoring back and pushing back saving electricity to the utilities. The collective action of doing this makes electricity available for other purposes. Fog computing, and that's, I'm in the last strip of my presentation here, but fog computing is important because imagine typically when we take an endpoint and we, from a sensor or thousands and hundreds of thousands of sensors, you're taking that information and send it back to the data center for processing and producing intelligent information and eventually outcomes, then all that information is constantly flowing through the WAN networks, whether it's LTE, LoRa, whether it's an optical network, whether it's a cloud, whether it's a Wi-Fi network, whatever you can think of. But still, lots of traffic from these hundreds of thousands of sensors, all sending that back to the data center on big servers. So this is not going to work. Over time, you will need something whereby you can actually process that information before it hits the data center, hence alleviating the quantity of information you're going to have traveling over the WAN network. So it's possible nowadays with gateways that are very close to the sensors, collecting gateways, to actually process part of that information, pre-process it, and then digest it, and then send the result of the processing to the data center. So it makes it for a lot less data traveling for nothing to the data center, but it will be data that is already prepared and pre-processed. So it's gonna make life much easier, a lot less data to process for the servers, because some of that job will already have been done in applications sitting in these concentration gateways that you have all over the places. Those are the gateways closer to the sensors collecting the data. So fog computing and mist computing, there's all kinds of names like that you're going to hear left and right, is probably part of the architecture of the future. We're going to see a lot more of that in the near future because of the quantities of sensors that we're going to see. Just to give you examples, it may be a shock to you that 30 minutes of flight could generate up to 10 terabytes of data. Not megabytes, not gigabytes, terabytes. If you take all the telemetry you can take from a plane, plus the HD imaging that you want to capture in order to do or analyze structural failures on a plane, you could actually end up with 10 terabytes of data in 30 minutes. How do you send 10 terabytes of data to the main data center via a radio link? Possible. The plane would have crashed by the time it's all gotten to the data center and analyzed. So you need pre-processing right on the plane, and that's what fog computing is all about. Pre-processing, then you send the result of that pre-processing to the data center, which will complete with more thorough data analysis. But that's one thing that you're going to see more and more. Same thing for wind turbines. Wind turbines, you can have up to 200 sensors in the head of a single wind turbines. Imagine a whole park, farms of wind turbines in the mountains, lots of data to analyze. It's impossible to think of sending all that back to the data center for analysis. You need pre-processing. Once again, that's what fog computing is all about. Most of these gateways that I showed you, like the one that I was showing you that we put in buses, are capable of doing that. They run containers and VMs, and they're capable of running application from different vendors and can actually do that pre-processing and sending the end result of that processing. So I believe that's my last slide, but it's just give you a logical representation of how the fog computing is actually happening, where you see those devices at the very bottom, and then the actual gateway, routing gateway. That's where we're good at. Cisco, we're a networking company. We're not a sensors company. We do our processing there and then feed that back to the application. So thank you very much for your time. I appreciate you listening to me. And as I said, if you have any more questions, we brought in a couple of fancy devices, especially LoRa-based sensors. And if you have any questions, we'll be more than happy to talk to you and provide you with more details. Thank you.